Hi guys, welcome back to HSC Standard Math Hacks, where we give you tips and tricks to do well in this standard maths exam. So in today's video, I'll be going through one of the most favorite topics of examiners. This is about normal distribution. And the topic I'm specifically talking about is about Z-score. And this question has appeared quite a lot of times in the exam, and many times it's not even evident that it's asking about Z-score. So I'll take you through all of that. But before we start, I want to take you through a little bit of theory. And usually I don't do this, but I think for this particular type of questions, this theory is very important because many of the questions ask you for the application of the Z-score, not specifically directly asking about the score. So if you go to topic 15 on Study Ninja website, you will find all the details on what I'm talking about. So here you've got the notes, and what I want you to tell you first is, before telling how to calculate the Z-score, why do we need the Z-score? Because if you want to know how to calculate Z-score, that's pretty much this formula that you need to know. But before coming here, let's talk a little bit about what is it, why do we need it? So the thing is, many times observation values are not comparable when taken from different samples. So let's say I tell you there is a student who scored 65 marks in an exam. Just by knowing that someone scored 65, you can't really tell whether that mark is good or bad, because you need to know how well others did in the same course, same exam that they were sitting with him. But if I tell you that the average score of all students was 70, then it's it's not as great. But if I tell you average score for the rest of the class was 50, then it's a good mark, right? So you need that relativity. Then going one step further, the average mark itself is also not enough. I'll give you these two examples, these two scenarios. In both of these scenarios, the student has got 65 marks, whereas the average score in both of these scenarios is 70. So if you take the average of this and average of this, they both would be 70. But if you look at individual scores, you would feel that the student hasn't done that bad. It's just only one student scored 100. That's why the overall average went up. But apart from this student, student 1 has second highest mark in the class, which is not bad. Whereas in this case, the student's mark, even though it's 65, everyone else scored better than this student. So it didn't do as well. To capture this is where we need the Z-score. What Z-score does is, now coming to how it calculates, is you take the observation value, which in this case is 65, you subtract the mean from it, and then you divide it by standard deviation. So it's a standardizing way to compare different numbers. So the Z-score in the first scenario would be minus 0.283. Minus in this case is indicating that the person scored below class average, and 0.283 you can think is how far from that average the score was. Whereas in scenario 2, it's also negative, but it's quite far from the mean as well, because this number is more smaller than this number, right? So by comparing these two numbers, we can tell, okay, this wasn't as bad compared to this one. Once you know this theory, now let us jump back and actually look at the actual exam question. We start off by looking at 2017 question 13. Here you've got the heights of year 12 girls, and you're told it's normally distributed. You're given mean, you're given the standard deviation, you're given the height for a particular guy, and you're asked to calculate the Z-score. So pretty much everything you need in the formula is given to you, right? So you're just gonna use this formula, observation minus mean divided by standard deviation. So in this case, your observation is 154. You subtract the mean, which is 165, and you divide it by 5.5, and that will give you the Z-score. It can't get simpler than this. This is the easiest way a question can be asked, giving you the marks in the tray. Then moving on, 2010 question 24C. you're given a mean, you're given standard deviation, you're given Jason's mark, which is 115. Exactly like this question, you're asked to calculate the z-score. So you're just going to use the formula and in the same way as we did there to calculate the z-score. Here is a bit of a twist though. In this question, what you're being asked is Mary has a z-score of 0, and you ask what is the mark she achieved. So it's basically same formula, but in this case you are given the z-score. You're told the z-score is 0. So what you need to do is remember the formula again. 0 is equal to observation, which is Mary's marks, right? Mary's mark. Then subtract mean, which is 100, divided by 10, the standard deviation. And then you solve it. So it's just the same formula, but asking you a different part of the formula. Similarly, it could have asked you to calculate the mean by giving you Mary's score and the z-score, or to calculate the standard deviation. Uh, Here it's already given, but it could have been done this way as well. So be prepared with that as well. Finally, this part I'm not going to cover in today's video because this is about the empirical rules, which I will cover at a different point in time. Then 2011 question 27C. You're given the mean and standard deviation of two brands, brand of bulbs. You're told that brand B light bulbs have a life of 400 hours, and you're asked to calculate z-score. Again, straightforward formula. You've got 400, you subtract the mean, which is 500, and you divide it by the standard deviation of B, which is 50. Pretty straightforward. But this one is very interesting, and this was the whole reason I wanted to teach you the theory behind the z-score, because it is these kind of practical questions that I think they're going to come more and more, and this is where the application lies. You're told that the light bulb is considered defective if it lasts less than 400 hours, right? And you are given a claim. Brand A light bulbs are more likely to be defective than brand B light bulbs. And you're asked whether this claim is correct or not. The way you would do would be, you can't compare the means and this with the standard deviation as we saw in our example when I was talking about the theory. What you need to do here is calculate the z-score. So you already calculated the z-score for brand B. You would do the same thing for brand A, which would be again 400 minus 450 divided by 25, and then compare which of these two is greater. And whichever is greater, they last longer, they are better, and then you can compare whether this claim is correct or not. Moving to 2013 question 29b. Here you are given a mean, and you're not told about the standard deviation, but in the first part you are asked to calculate that standard deviation. So you're given this sample, straightforward, you need to calculate the standard deviation. So not that hard. Then you're told that, okay, one thing I skipped here, Ali's class did 2 geography tests. So this is the result of the first geography test. On the second geography test, you're given the mean and you're given the standard deviation already. Then you're told Ali scored 62 on the first test. Then calculate the mark that she needed to obtain in the second to ensure that her performance relative to the class was maintained. Again, it's not directly asking you about the z-score, but you need to think about it. That the performance relative to the class. How do you measure performance relative to something? It's through z-score. So what it's saying is that you need to calculate the mark in her second exam so that the z-score from the first test is equal to the z-score of the second test. So from this you need to figure that out. From the sentence you need to figure this out, that it's asking about the z-score. So what's really asking is that you calculate the z-score of first test. First test z-score would be 62. This is the test score minus the mean. Mean is 68.5. And you divide it by the standard deviation, which you would have calculated in the first part. Once you have this score, and let's say this is minus zero point 0.3, I'm just making up a number. The question is asking you that tell me what mark Ali needs to get this one, what marks it needs to get in the second test so that it has the same Z score as first test. So that's where you're again going to apply the formula, this time with the second test's mean and standard deviation, which would be this, and then you're going to calculate the mark. So it's not, the formula is still easy, it's just the application that you need to really focus on here. So moving on, 2015 question 28b. Here you're told that results of two tests are normally distributed. You're given the mean and standard deviation of these two, mathematics and English tests. So mean and standard deviation. You're told that Christoph scored 74 in maths and 80 in English. He claims that he has performed better in English. Is that claim correct? Again, it's nowhere asking you about the Z score. You need to figure that out, that it is asking you about Z score because it's a relative performance between two things. So essentially question is asking you determine what the Z score of maths and English is and tell me whether the Z score of English is higher than the Z score of maths. That's when English would be better than maths. So straightforward, use the formula, calculate the Z score and tell whether the claim is correct or not. Moving on, 2018 question 27e. This one, Joanna's mark in the physics test is 70, the mean mark is 58, and standard deviation is 8. Calculate the Z score. Straightforward application of the formula. This is what we have been seeing here, and I think a few other questions as well. And then here in the biology test, the mean mark is 64 and standard deviation is 10. And you're told that the Z score is the same in both physics and biology. So whatever Z score you calculated here, which say for example is 0.3, again I'm making up, you're told that biology also has that 0.3 Z score. So then you need to calculate the mark in biology. So if you know that Z score is 0.3, you need to calculate mark. You're given the mean and you know what the standard deviation is. It's pretty much what we did in this question to find this part. Okay, last one, 2020 question 8. So this came in the recent exam. Here you are given John's scores for 3 different subjects, the mean and the standard deviation of all those scores, and you're being asked which one is the strongest subject, which one is the weakest subject. It's nowhere asking you about the Z score, but again comes down to that application which I've been stressing over and over. If you know this is about Z score, then all you need to do is work out these 3 Z scores, straightforward formula application, find out which one has the highest Z score, which one has the lowest Z score, and then the one with the highest Z score would be his strongest subject, and the one with the lowest Z score would be the weakest subject, and you'll figure out the right option from here. Now, having talked about all this, I think in the past this has been tested quite well, and I don't think it can go ridiculously off from what has been tested. But what I do feel is these applications is where you need to focus a lot more on and be very well prepared in terms of how different ways they can be asked, just like this and just like this one where there's a claim and you've been asked to test whether it's correct or not, and like this one, not talking about Z score at all as well. So these are the ones you need to be careful. Otherwise, just be confident what the Z score is, why do we use it, the formula to calculate it, and I think it will be okay. Then if you haven't seen the mock exams, I would encourage you to attempt mock exams on our website. It's under chapter 20 on Study Ninja. This is where I have put together these kind of different types of questions that can be asked in the exam. And finally, please join the HSC Standard Maths 2021 Facebook group as well.